Mitsubishi Red, what is happening? Mark Bare Naked Willie, how are you, my friend?
Dave Cooper Live. We always love the red, white, and blue. And today is a special Friday, isn't it, brother?
It is a special Friday. We have a special guest making their second appearance on the BS Friday show today, and it is with good cause because we love talking about electrification and ventilation and all things in between.
I love it. I didn't know whether you're going to do ventilation and electrification or electrification and
Electrification and
ventilation, right?
ventilation.
It's say that 10 times fast both ways.
Right. Alternate both ways, right? Alternate both ways. So awesome, man. It's kind of funny. I went with the red background. You went with the red Mitsubishi shirt and the Mitsubishi hat. So it's funny how we're starting to, we're like an old married couple, like where we're just starting to vibe off each other. Like we just know, huh?
We're like an old married couple who never met.
That's right. I know it. Maybe that's going to happen here real soon. Hopefully this COVID stays at bay and we can keep doing what we do. So, Mark, what have you been up to this week? Anything good, glorious, fun?
You meet people, right, Dave? You connect with people, you learn from people, and you share with people. So that's the general, right? You do it, I do it, the people we surround ourselves do it. And this week's been a 4 to 5 a.m. start and a 1 a.m. stop. I don't know. The good Lord gave me the energy to put the throttle down, so I'm moving.
Well, you know what? We got to keep moving forward. This whole industry is moving forward, and that's why we do what we do. So it's going to be a lot of fun having Mike on the show today. So listen, everybody, as Mark will tell you, we are always bringing you the people and the processes that are building it better. Our guests and topics include experts in building systems, building science, building codes, and the tech used to build it better. Mark, Willie, are we always searching out the best and the brightest to discover innovative ways to build?
All day, every day.
All day, every day. And that is what BS Friday is always about. Building science, building systems. And Miss Willie would say about 20 other different BS words that we can throw in there. So what do you think? We got a presentation today. We got some PowerPoint slides or slide deck that we're going to go through. We're probably going to have a little bit of humor while we do it because we're just good with that. And, I think Mike's easy enough that we can have some fun with. What do you think?
Mike is a great fellow. The cat's out of the bag. You said Mike, and I think everyone's been reading our posts. The cat's out of the bag. It is going to be fun. I can't wait for the Cooper train to come through one of the cities that Mike's traveling to, so you two can, do the whole fist pump and get to know one another.
Fist bump. We can do that virtual too, right? I'm getting used to that backwards, All right, let's do it, man. Let's hop into the show. But first, everybody, thank you for joining us today because we are live on. Go for it, Mark. What are we live on today?
Well, we're live on Facebook. We're live on LinkedIn. We're live, and we're always on YouTube for your likes. Subscribes. And there's one more, Dave. Greg Ugaldi's always on it. What is it?
That would be Twitch. And why do we go to Twitch, Mark?
Well, first and foremost, because Greg brought it up. Secondly, because you have these generation of folks that are into Minecraft and these incredible electronic gaming experiences, and we can move them into the world of BIM. We can move them into the world of digital twinning and CAD and SketchUp and all this wonderful software that helps us run our jobs. So Twitch is the connection that we need for the next generation.
That's right. In fact, I think we need to start a show, Mark, playing a game of Fortnite together, just to show people how incredible the virtual world can really be and how it's being adopted into the built environment, which is awesome.
I've had a pinball machine and I've had Atari 2600. Is it any different than that?
A little bit, little bit. It's definitely not like playing Asteroids.
Yeah. Well, Asteroids was advanced. I was still on Pong.
Right.
Love it.
That's right. Pong from the first Nintendo. All right. Without further ado, why don't we hop into this? Let's bring Mike Schaefer into the crowd. What is up, Mr. Mike Schaefer? How are you today, my friend?
Good afternoon here. So I am in Central Time. So good afternoon, good morning, maybe to you still, Dave. Thanks for having me. Excited to be
only
here.
An hour behind, right? 2
Yeah,
hours?
yeah. I don't know time. I'm about as far along with technology as Mark is. Miss Pac-Man, maybe. I don't know.
Yeah, Miss Pac-Man. So Dave jumped from the Eastern Time. You're in LA, Dave?
We're right outside of LA.
So normally it would be 1 o'clock Eastern. Now it's 10 o'clock Pacific, and we're at 12 Central. So Dave, we're actually in the future for you, right? We're coming from the future.
That's technologically advanced right there.
that is. Mark, you have been having some late nights and early mornings, huh?
When you read articles, your eyes go like this after a while.
You start to get blurry.
Perfect. All right. Listen, Mike, you're back. You did the intro for us last Friday. Mark liked you so much, he said, why don't you come back this Friday? So that's always a plus. And we've seen you here and about and around, over the year. But, Mike, we ask everybody on this show that we want to know everything about you from the moment you were born to this very moment in time. Do not leave out any of the good, gory stuff from the hospital, or Mrs. Willie will call your mother and promise you do not want that, because she will drag out all the embarrassing moments in your life, and we'll bring it on the show. So, but you only have 2 minutes to do it, so have at it.
So I am born and raised in Illinois, actually Central Illinois. So I actually grew up in Central Illinois, and I've been up in Chicagoland area where I'm at now, far northwest suburbs, for about 10 years. We're somewhere around 10 years now. I entered HVAC back in, rack my brain here, it'll date me a little bit, but back in 2004. So I'm 17 years in the industry. I started working on the contractor level, not knowing the first thing about a furnace or an air conditioner, and learning that along the way, and worked for distribution and manufacturer here at, get my camera up there, Mitsubishi Electric, heating and air conditioning since 2014. So I'm a little over 7 years now with Mitsubishi Electric. I worked all in Chicagoland area I started actually on our commercial side of the business, working with our 3-phase VRF products, moved on to our residential side, and I've been in our performance construction group for some years now. So now currently I'm the senior manager of performance construction. So I cover our central business unit, which is 12 states in the Midwest, as well as an additional 7 states in our Southwest business unit. So a really big, large chunk of the center of the country. And what I do during that in this role is work with builders, work with architects, work with contractors, our distributor partners, engineers, anyone and everyone that wants to and learn how to integrate air source heat pumps into your new construction as well as retrofit projects. So that's my goal, is to get more air source heat pumps out in the market and to do it correctly. So that's kind of what we'll talk about today.
So before we jump into it, like we always say, there's a couple unique words you used. One is VRF, one is heat pumps, and one is air source heat pumps. So sometimes the world only understands thermostat, and that might be too big. So can you dial us in to entry level, brother?
Yes. So we'll go back to the first one. First, I said VRF. So VRF refers to variable refrigerant flow. So that's a difference with everything that we'll talk about today in relation to what a lot of people might be used to, how their home is cooled, essentially, really more from a cooling standpoint. It's varying refrigerant flow instead of the air conditioner that most of you may have in your home, which is one stage all the way on, giving you everything it's got. We vary the refrigerant flow. So vary the energy use, vary the comfort factor, vary everything with it. So variable capacity. And then heat pumps is a way to heat and cool with one piece of equipment. So the easiest way for somebody that may not understand is everyone has a heat pump in their home, and that's your refrigerator. So your refrigerator is a heat pump. It's removing the heat from the food that you put into the refrigerator. And if you feel below the refrigerator, you have lukewarm air coming out, it's exhausting that heat out. So that's what a heat pump does, is it removes the air from outside and transfers that inside to heat the home in the winter. And then air source heat pump is the air side of that. There's two types. There's air source and there's ground source. It's where you're getting your heat from. So we'll talk about air source heat pumps today.
I love it. So that's funny. I got 2 heat pumps on my motorhome.
See?
I can use either the AC or the heat pump, which is amazing. And it's good up to about 40, 45 degrees. It still throws some pretty good heat. But after that, then I got to go to the old propane.
And we're going to talk about that today.
Yeah. And in the summertime, Dave, you could just open your fridge, right? That'll cool your space.
Well, that's right. It would cool my space, but all the ice would melt for sure.
Yeah, it creates other problems. Please don't do what I just said. All the advice should come from Mike. That was an anecdote. Mike, that's a great description on what those are. And the other thing is that they're very compact these days, and they're allowed to when something changes in the building, be it from the environment or from the people over, they also adjust very quickly.
Yes.
And they're wonderful in terms of that capability, and they're electric. They're based on electric, so that is a really unique thing because a lot of these areas you don't have gas today. We're talking about the heating season. You don't have it available, and it's really beneficial to have a source to go to so that you can provide that warmth with the simple electricity.
Exactly. And we'll talk about electrification here and what is the right way to electrify, right? Strategic or beneficial electrification. Because it's not just making everything electric, it's doing it the right way.
Amen.
About that.
All right.
Well, and
you want to jump
right
into
way.
it, Mike?
Sure. Whenever you're ready.
So, Mike, one of the things that I really want to understand is, are the systems today like the systems of yesterday? When I say that, like we grew up with either it looked like an octopus in the basement with stuff coming out everywhere, right? And then it started getting into the European style where you have the mini splits on the wall. Mm-hmm. So all of this stuff, it'd be real interesting to understand like where we were and where we are today and what that value is as we go through this. So those that are joining us understand the difference between, what you're going to talk to us about today and why we need to be looking at systems such as the Mitsubishi systems versus the systems of the past, because it is not the same. And I think that's really important to get across.
Absolutely.
If you think about it as an appliance, and I don't know if that's done in the industry, but their appliances have become sleeker, have become fashionable, right? They're almost, I would venture to say, sexy. So when they're a part of our environment, they're taking up so much less space, and the enclosures, when they are visible, because they're not always visible, right? There's the cassettes you'll get into. I think, Dave, they're sleek. Before you kind of hit them away, and then, like you said, it was a great description. You have the whole octopus thing going on. All right, Mike, you do the tech, and we'll be on mute, brother.
All right. Please feel free to interrupt me, as you would anyway, Mark. But feel free to interrupt me because as I flip over here, I will lose you. So thank you, Dave. Like everything you mentioned is exactly what we're going to talk about today. So you would have think that you had a lot of time to study my slides, which I know we haven't.
I haven't even seen them yet.
I know, that's what I'm saying. I really would have think you would have actually helped me put this together, but that wasn't done. So everything we talked about is what we're going to do today. But I tore some old octopuses out in my day. They still exist out there, or at least they did, 14 years ago when I was tearing them out. But we are not that. So we're going to talk about everything else. How I wanted to start though first was about electrification. So we kind of understand what is electrification and where do air source heat pumps fit into that discussion. So first off, we're talking about strategic or beneficial electrification. And what that means is how to electrify appropriately. So electrify means reducing our reliance on fossil fuels, right? Reducing our carbon footprint. You might hear it as decarbonization, right? But electrifying. And as you can see, there's been some studies done over the years about electrification. As this slide is, a year or so old, it's probably quadruple the amount of studies that we've seen out there now. But it's how do we electrify, and how do we electrify beneficially and strategically? If we look at this little snapshot right here, talking about fossil fuel usage, this is just in New York and New England. So just in the Northeast. If we look at what is actually utilizing the most fossil fuel in the world, it is about 46% of that is due to residential and commercial space and water heating, right? The rest is, you got a little bit of industrial process, but the rest is actually transportation, right? So we already know, you hear about this way more in the everyday public about electric vehicles, right? Less than you hear about electrification of heating and cooling and water heating and cooling every day in the public news. But we're taking up 46% of that to heat and cool our homes and our water and our businesses. So we know that that is a huge chunk of fossil fuel usage that we need to get rid of, right? We need to get off of that for climate reasons, for everything associated with it. We need to do it, but we need to do it strategically and beneficially. And what that means is not going into all of these instances and just saying, we'll just flip everything over to electric and use electric resistance heaters, right? So think of like baseboard electric resistance heaters or an electric water heater. It's doing it with ways that use less energy than just straight electric resistance. So it's moving over to electric usage for heating and water heating and cooling, but to do it effectively with air source heat pumps or with ground source or just with heat pumps in general that are a lot more efficient than just straight electric resistance heat. Not talking politically by any means whatsoever, but just showing, so we know we have to do that. And where does that go, right? What does that mean? And why do people need to be interested in that outside of just the climate implications and everything else associated with it? Why do we need to be on top of this subject, and why it's important, not only for the HVAC industry, but for the builders, for, anyone doing renovations, remodels, anything in general? Why is this important? We look at our infrastructure plan that we have out there coming forward. It's a $2.2 trillion infrastructure plan that is focused on retrofitting and building new homes, right? So build and retrofit 2 million buildings. We want to upgrade the grid, right? Support renewables, because that's what's important, is we want to be able to go to electrified heating and cooling equipment and everything else associated with it, but we need a clean grid to do it. So renewables is very important. Building 500,000 homes for low income that we want to be all electric, and on and on and on. The steps are there to get to strategic electrification. It's coming. It's already here. So we all need to be invested in why this is important. So outside of that, that's kind of my spiel on why electrification is important, right? So how does Mitsubishi Electric and air source heat pumps fit into that? How does this equipment work? What does it look like? Is it the octopus? It's not the octopus, right? Is it sleek? Is it sexy? Boy, I think it is. There's a lot of things that we'll talk about here moving forward. So first, with Mitsubishi Electric, on our residential and light commercial side, we have our M&P series equipment, which is what we're going to see here. I'm going to go a little bit more in depth into equipment down the line. This isn't a product infomercial, but I need to show you what we're talking about. When we talk about M series or MXZ, you might hear me say, or P series. M series is primarily our residential lineup. MXZs refer to multi-zone equipment, which I'll speak to. And then P series is light commercial. That's kind of how we lay everything out in lingo. But we have cooling only products. We have regular heat pumps, and we have cold climate or hyperheating heat pumps. And I'll explain the difference between those. And Dave, you kind of already hit the nail on the head earlier with your heat pump that you said, once it gets about 40s, I got to kick it off and turn on the propane. We're going to talk about that and ways to mitigate that. That's on our residential side. We also have our City Multi VRF, right? So variable refrigerant flow. We're back to some terminology we discussed for commercial applications. We do some of this in residential too. It's usually very large residential homes, but Mitsubishi was the first 2-pipe simultaneous cooling and heating system. What in the world does that mean? That means that we only have 2 sets of copper line sets or 2 pipes, and simultaneous heating and cooling is heat recovery. So that means as we're heating, instead of taking, or as we're cooling, instead of taking the waste heat and exhausting it outside, we can move it around in our system so that one unit outside can provide heating and cooling at the same time. So very, very interesting technology. And then from a control standpoint, we can integrate with anything, but that's as deep as we'll get into on commercial. We'll spend most of the time on residential today. Like I said, I don't want to do a product infomercial, but I do want to show you just from a snapshot, and this really fits into what Mark mentioned earlier about how units used to be, or you only think of a wall mount unit. This is a snapshot of our residential product lineup. It has everything. So, if we start up at the top, we have ducted units, we have ductless ceiling cassette units, floor mount cassettes, and we'll talk a little bit more about how we could apply these. And then we have all these different variations of ductless wall mount units in the middle. There are a lot of different choices to choose to pick from when you look at how to integrate an air source heat pump. And I'm going to talk about the differences in air source heat pumps as well too. But I just want to give you an idea of the breadth of product and what we're actually working with and all the different capabilities that we have. In my side of the business, on the performance construction team, I'm not just about moving a box, right? And Mark knows this, and he knows how in depth I can get with projects and everything that we care about. It's comfort, health, and efficiency. It's not just putting a box in a home. It's how do we look at this house from a holistic approach, right? How do we figure in the most comfortable system, the healthiest system in relation to indoor air quality, ventilation, which we'll hit on, dehumidification, which is really important in parts of the country, and what's the most efficient product? So I can take any of those products that we've shown and put them in any home, but how do we do it effectively? And that's what we really care about. We're really involved in the process. So when we work with builders and contractors, we're looking at how do we do this and how do we do this effectively? It's not just throwing a box in the basement and octopusing it out to the rest of the house. We really want to be strategic and careful on how we design our systems, because we can design a system that works perfectly, or you can misapply systems very easily as well. So we're very involved in that process. I did this a little while back, and this is kind of what I wanted to hit on, because we talked about electrification. So I'm worried about all electric. That's what I'm talking about today. Can we integrate with homes with gas in them? Absolutely we can. We can do spot heating and cooling, or add cooling into a home that has a boiler heated system. We do those things every day. Mark, think about how many homes here in Chicago have boiler heated, hot water heated homes with no central air conditioning, right? Our systems are added into those on a daily basis. But I want to talk about all electric homes. So I kind of dug this down to 3 rules to live by for an all electric home, whether we're building a new home or we're retrofitting a new home, right? Are we renovating or retrofitting a home and moving off of gas to all electric, or just off of gas heating system to an all electric heating system? Rule number 1 for me, as it always is, anytime we're talking about air source heat pumps or electrifying, is tighten up the envelope. Pretty simple when we break it down. The lower the heating and cooling load that a home requires, the less energy, and in this case, electricity, the HVAC system will use, right? Lower load equals smaller HVAC system required. That's what we want to focus on. We're not putting in 120,000 BTU gas-driven furnace, right? We're looking at much smaller, compact, higher efficient, lower BTU size air source heat pumps. So we want to tighten up that envelope so we're not using as much energy. So we have less of a heating and cooling load. So tightening up the envelope is very important. When you do that, though, it opens up this can of worms that you need to address, right? So when we talk about high performance homes, meaning tight homes, right? Energy efficient homes, they have extremely low sensible cooling load. So sensible means how many BTUs of air conditioning I need to drop the space temperature in a house, right? If it's 75, how many do I need to get it to 73 kind of thing? The old rule of thumb, back when I started in HVAC, was about 400 square foot a ton, which meant that if you had a house that was 1,200 square feet, you need 3 tons of air conditioning. Rule of thumb's out the window. You cannot do that anymore with high performance homes. Now we're looking at 1,000 to 1,500 or more square foot a ton. So these homes require much less heating and cooling in that. So sizing becomes extremely important when we're looking at high performance homes and electrifying. Latent loads remain fairly constant. So what in the world is a latent load? So in cooling, you had sensible, which I explained, how many BTUs I need to remove to drop the space temp. Then you have latent load, which is how many BTUs I need to remove the moisture in my home, right? So dehumidification. So while these high performance homes have low sensible loads, latent loads remain fairly constant because they're so tight, right? You've created such a tight home that humidity has nowhere to go. The moisture stays in the house. So we have to focus on that. Part load runtime is increased. What in the world does that mean? That means I'm not running at full capacity the majority of the time. Because my structure is so tight, I'm running at part load, which means I don't need all of my 3 tons of cooling all of the time. That's where variable capacity equipment comes into play. This makes the selection a bit more difficult. Mechanical ventilation is now required, right? Not only by code, but because I'm building such a tight house, ventilation is an absolute requirement now. And supplemental dehumidification may be required. Why would the supplemental dehumidification be required? Well, we know in humid climates, dehumidification is important. But even here in Chicago, if I have a very low cooling load, my latent or my humidity level can still remain high even when my cooling system is not running because there's no call for it. So you may need supplemental dehumidification in a tight home. So rule number 1 is tightening up the envelope, but you need to address all of these things to do that
Mike,
effectively.
I'd like to keep this slide up for a minute, Mike, and give you a chance to grab some of that water. It's perfect. You're going to need another glass, I think. This slide is very instructional and might be a little advanced for some folks. But that's okay. It's a learning lesson, right? Not for you, Dave. You took the training with Sega. You're covered. So the sensible loads are words that you want to hear from your team, whether it's an existing project, a new build, residential or commercial. These are terms to familiarize yourself. So it's clearly stated here, but it might not be clear. And then the latent loads are often what turn around and surprise folks. So you might hear of the really awesome project where everyone did the planning, they did the right selection on the envelope, which is the red line exterior, and the mechanicals, but something was missed. And that latent load comes out, right? It comes out, and then there's still a fix for that. Don't be scared.
Right.
What you're experiencing in the building, if something was missed, you bring up. And in many cases, I believe, on lessons learned that I've been a part of, it's been the latent loads.
Yep.
The sensible loads are figured out really well by the professionals and the suppliers and manufacturers.
Yeah.
The load runtime is dead on. Of course, the selection is it might be considered difficult, but very possible, right? Because you're honing it in. It's always possible. It's just you're putting on another cap and you're talking. 2 heads are better than 1.
Yep.
And this is my favorite. Mechanical ventilation is required. And you made the point, not just for code, because the ventilation is required because, let's face it, there's more materials today, and we're buttoning up houses sometimes because it's a plan and sometimes because it's by accident. So the reason it's required, Dave, I'm almost there, brother. The reason it's required, it's real simple. It's supplying an open window without opening a window, and in cases, right, we have the fires that the Coopers just drove through. You're not always capable of opening up your shell for that nice fresh air, or to get out the bad air. Right, that mechanical ventilation is required for you, for people. It's beautiful. And supplemental dehumidification, not a problem.
Yep.
Very, very good. This is one of my favorite slides in all 64 episodes, Dave.
So I have two questions on this because I, as a builder that has built a lot of homes all the way up to LEED, never a passive home, I would always be asked when we talk about the building envelope, well, this is just, why can't I just open my windows? Why do I have to build it so tight? I mean, this makes no sense. I'm living in a plastic bag now, right? So if we break it down, let's get out of this technical stuff.
Yeah.
That's what 75% of the world thinks, right? Or the United States versus those of us that know the science. And since we have so many people now joining the show that are here to learn about the science, is there a simple explanation for why that is?
Yeah, I like to look at this. I go, every house, whether it's tight or it's not, you're incorporating fresh air into that, or you're incorporating air into the house, right? Which means every time you turn on a bath fan, every time you run your hood in your kitchen, you are now creating that pressure in the house where you're pulling air in. Now, do you want to control that air that you're pulling in? Or do you want to just pull in the air through your outlets, through the cracks in your windows, through the dirty, insulation in your walls, through your attic, radon through a crawl space? Or do you want to control it through mechanical ventilation so the air that's coming into your house is filtered and it's conditioned through an ERV? And then now you're getting good air in your house as opposed to just whatever's outside.
I got one more question.
Yeah.
And then we'll get back to it. All right. So here's the other side of this. If I'm Mitsubishi and I really want, there's a lot of homeowners, a lot of DIYers that are now doing these mini split systems on their own. So there's even companies that sell them out there. But how does one know the checklist, such as latency load, to be asking? How do they figure this out on their own? Is there a checklist? Because most builders have not gone back to mechanical school. They're aging out. They don't know all of this information and all this data. So how do we have something that can educate so people ask the right questions? Because I think the consumer really needs to be knowledgeable on these things because the trades are so busy. They're not going back to school to learn this stuff. They're just doing it the way they've done it because it works.
Right.
And that's not all of them, but that's a good majority of them.
And sometimes equipment, because of how we did it before, was just oversized, right? And it certainly wasn't just the mechanical world. It was because we didn't know what was in the walls and they accommodated extra for it. This isn't a finger pointing operation, so please don't mistake my words.
No, it is not.
But the manual J and the manual D is their sizing for the volume of the space based on what the space is built on, I guess would be the clearest thing. That doesn't mean that there's been a manual J or a manual D on your project. You might have your Uncle Cliff that has an extra unit and he just puts it in, right? I like my Uncle Cliff. Put it in, brother. But it's not just about that. David, was really brilliant what you said about opening the windows. So you're in California, right? And your house back east is going to have a visitor. Your brother's coming over. Well, you want to make sure that building is breathing effectively while you're not there, because it's really hard to open a window in Connecticut when you're in California. So a lot of it is you've got these smart devices now, and so the compatibility of systems with different integration allows your home to operate effectively with the tools that are now available. It's really abundantly available with the right companies.
Right.
Yeah, I agree with that. All right, listen, everybody, if you're just joining us and you are not following Mike Schaefer on LinkedIn or Facebook or any of the other social media platforms that he may be on, you're wrong. You need to follow Mike Schaefer. And if you're not following what he's doing with Mitsubishi and following Mitsubishi, you're wrong as well, because they are putting a lot of time and effort into not only building science, but also in the modular and panelization world. And they're doing a lot of research to help better a systems built approach. So all of these things are coming together. And Mike, if I misspoke, please let me know, but I don't believe I did.
Perfect.
So
Dave,
make
I
sure
have
you're
a-
following us. And if
I
you
have
are
a
not
slight echo.
subscribed, there's
I'm
an echo
sorry.
coming.
There's a slight echo from you. I noticed I'm not getting it from Mike, and I don't know if I'm producing an echo. I'll take all responsibility.
I'm
Try it again, Dave.
unmuted, Mike. Are you still getting the echo?
No.
Okay. Yeah, Mike, I think, remember I said it might switch over, so we might have to go to the, or just
Oh,
turn your
something
volume
happened.
down, Mike, and that should help us.
Got it.
It's feeding back through Mike. So,
Yeah, Dave, I cut
ahead,
you
Mike.
off when you were saying hit the subscribe button, right, for more YouTube channels. And the YouTube's exploding. I spent my Sunday looking at some YouTube videos that I missed. So the audio's better, I'm thinking. Can we pause for a second and jump to this awesome audience?
Yep.
I know
That's where
Ben
we're headed.
Hershey is out there, and I apologize for the people I missed. I was really dialed in to the presentation. Yeah. So for folks that don't aware, I've known Mike for a long time. I've seen him present, and for full disclosure, I've worked with Mike. So when I see the products that are up, it's always like when you call Mike, he's like, now hang on, Mark, you used that one last time, but we have this now. So more solutions come on board. So when you go back and watch the presentation, look at those different layers that are there. When you worked on a project last year, they might not have been available. And next year, there will probably be more. So there is constant advancements. That's the joy of our industry is it's not a written in stone. We've learned this, we have this, now we do this, and it's all available. I want to, if for people that are new to this, there's a really big book of options, and those options are solutions based on what we're able to accomplish today.
Yes.
We're just going to call it Mikey Likes It. Remember Mikey Likes It, right? The old Mikey will eat it. Mikey likes it.
I like what Mike likes. Really, love it.
All right, let's hit some names here. Happy BS Friday from Texas. Going to be a good one with Mike Schaefer. Good old Andrew Seeley.
Thank you,
Building
Andrew.
off grid using solar power only.
It's pretty cool because all three of us know Andrew, so it's nice when Dave and the guest host know Andrew. Andrew's awesome. Hey, happy Texas! Glad it's not raining today, Andrew.
Yeah, for sure. And I saw our architect buddy was out there with Andrew doing some videos and talking about what Andrew's doing. So he got the name of some pretty smart people working with him, and I think they're doing some videes. So that was exciting to see that. Mark,
Big
you happen to
Red,
know what that guy's
Stephen
name is?
Basic. Big Red,
Stephen
Stephen Basic. Yeah, he was on the
If you
scene.
get Stephen Basic, you get Stephen to your job site, you're doing something right. Or he's going to have the big red of truth out.
Well, if you're not doing something right, by the time he leaves, you're doing something right. You better believe it. He knows how to put the screws to you.
That's it. All right, Mark, here you go.
Sean Santamore, happy BS Friday with a PH. Our homes also need a good set of loves. This is a great show, and Sean and his team from 475 will be with us next week, y'all.
That is right. Sorry, I had to go look at the name of this next user here. Derek Coburn. See, he's got that setting turned off where it hides him when he comes to our platform here. My first BS session today. Well, listen, congratulations. I don't know if that's the same. Maybe that name's not right, but Jen looked it up. It said Derek Coburn.
Yeah,
Derek,
I can't believe this is your first one. Derek is a DC expert. His name of his company is Lumen Koch.
I think yeah. Right.
I asked Derek to present in one of our first couple episodes. I think he's still honing his presentation. Derek is a brother. and yeah, he's a DC expert. I'm for sure. There you go. Um,
Got it. Yep.
Yep.
Connected
So
when the
we
cars to
guessed right.
Minecraft.
Thanks for the background sleuthing, Jennifer Cooper. Beautiful work, LinkedIn. Please make your faces available. We want to see your pretty mugs like Buzz. Oh, sir. Can't ever say your last name, dude. The
Pulitzer.
buzzer.
Hold
Uh,
on.
happy BSPH Friday, y'all. Let's build. Yeah, Buzz. Let's do it, brother.
I'm getting Buzz a Buzz Lightyear helmet, man. Right at Disney. We're here. Buzz, look in the mail for your Buzz Lightyear helmet. It's coming.
Dave, the
your
name
way.
of his company is EcoBuzz, actually. Yeah.
Scott Farbman in the house. I'd like to see a future where we have the heating, cooling, heat pump, hot water heat pump dryer, and refrigerator all on the same refrigerant loop, sharing efficiencies and connected to one outdoor unit. Now, that's interesting.
We're not far off. We're not far off from tying in that water. So, yeah, it's actually there. So the refrigerator will be maybe a little double.
We're all waiting for that. My guess is you're going to see it in Scandinavia or Japan first. And then America will come around 40 years later and say, hey, yeah. Or maybe our RV market will have it. Maybe the Coopers will drive in an e-mobile.
Hey, we could be the test pilot for some of these new systems, right? Because it'll always be going through that high wind, hurricane, earthquake feeling down the road. So not only can you can test the efficiency of it, you can test the stability and the quality of the build.
And it's quiet, so it doesn't mess up when you're doing live broadcasts.
That's right. Hey, and for the offsite manufacturing space like modular, you could do all the testing for the installs at the factory. We could be the live test show, riding down the road for you.
Yes. Planning the future with a PH. Amen, brother.
All right. Go ahead. We got Jerome A in the house, Mark.
So, if possible, please cover your guidance on the importance of using proper adhesives and sealants to control airflow and concerns with mold and mildew, especially in modular buildings. Well, we had Cheryl Psycho on, and she covered that. And also, Jerome, a lot of applications do not require adhesives or sealants, right? When you get to the level of living building challenge, and certainly electively in many of the passive projects, they're not doing that. And the bonding in many of the modular wall componentry is already a beautiful no VOC bond. But you're right. The wording is correct. It's proper adhesives, or in many cases, there's not sheathing and those type of things. They're actually membranes, right? So Mike's covering the ventilation and electrification. Next week, we'll cover those membranes.
Membranes next week.
Hey, Dave, can you move our pictures around so I get covered up? Perfect. Now you're front and center, Mike.
Let's do a couple more, and we're going to get back to the presentation here. We're already 50 minutes into this, and these good folks have showed up to learn something. So we want to make sure that the hour they gave up, they get to learn what you have to present. So let's just do a couple more, and then we'll come back to the rest of the comments and questions in just a little bit. So I think this is – whoops, sorry about that. Go ahead, Jen. I overrode Jen. She got mad. No, I'm just kidding. How often is going up to 400 to 600 amp service a deal breaker? Builders complain about this all the time when we try to pitch all electric design.
It's honestly not much more from our dependence upon the equipment that you're utilizing. I mean, you may only need a 50 amp breaker with our stuff to electrify the heating system. So it's not substantially more than especially with a high performance home. It's probably going to be less from the heating and cooling aspect of it for how much electricity you need. Retrofitting a home or a very large home, you're going to have a little bit more. So it will add a little bit more of a draw to it, obviously, but it depends on the homeowner and what they want to accomplish.
Yeah.
If they want to accomplish an all electric home, then we got to find out why.
Well, sometimes, I've also found it's not the homeowner or the contractors; it's been the utility. So we had a 200 amp all electric house, and it was modeled and sized to do that. And the utility said, "No, we want the larger one because of XYZ appliances. Nothing to do with the ventilation and heating and cooling. It had to do with their stoves and some other stuff." But yeah, it was an all geothermal house. It operates at $40 a month, and the utility was wrong. Sorry, utilities, you were wrong. I know I'm wearing utility colors today too, so no offense. But we learn from pointing out that we don't always need to do it, and it's because of the efficiencies of the equipment that modeling proved it. And hopefully, the rest of our industry can benefit from it. So people like Scott can say, "Hey, nope, been there, done that. Don't need it. Don't need it. Don't need it."
Don't need it.
No need it.
All right, love it, love it. Next comment. What's a swamp cooler? Any links? You know what? There's a link at the bottom of that beer glass at the Passive House Brewery, I think, is where you'll find that. So you should go check that place out. It's pretty cool.
It's probably going to be a new beer, right? It's going to be a swamp cooler special.
swamp cooler special. We got to find a way to put a pH on that.
Yeah, we're not covering swamp coolers today, and I don't think they use swamp coolers in London.
All right. I saw something from Aaron Peterson pop up there. The big man in the house. And when I say big, he is tall. Are we talking central air today or or swamp cooler? It fascinates me that swamp cooler is much more efficient than central air.
Central, we're all talking all about central air, not extremely hot climate swamp cooler. Yeah.
Right. I have no experience in swamp coolers, and we're just gonna keep rolling, and I'll find some links and I'll drop them in the comments after happy hour.
Perfect. All right, next question. Alex DeCogne in the house. Well, here's somebody that actually knows something about heating, cooling, and ventilation. I do agree with Sean about getting good lungs for homes. This is why we have many of our units combined with Mitsubishi units, creating a unique and high-quality performance systems. And if you do not know who Alexandra are, I would be remiss to not say, during one of our BS Friday shows, we had Alexandra on the show. Mark knows the exact number because he knows every episode by memory, but I'm not going to put you on the spot just yet, Mark. By the end of the show, you let us know where that is so people can go see what Alexandra had to say.
I'm going to give it a hint. Alexandre was in the top 10. I mean, the first 10. I don't want to rank them. That's going to get me in really hot water, and this episode's not about hot water. But
you have to do a lot of scrolling then.
Alexandre and the Minotaur system do talk and work with Mitsubishi. When you get to the level of performance that these two companies bring to the market, the compatibility is something that they chose to do. Not all manufacturers can do that. That's not a slight on all manufacturers. We're talking about advantages and solutions. So thanks for being here, brother.
Yeah, very much so. That's really cool that you showed up and spending your time with us today. All right, Mike, let's get back to our presentation, and let's see if we can get through the rest of these slides. Then we'll get back to saying some hellos to folks.
Yeah.
I'm going to put myself on mute, and Mike, I'm going to take screenshots of this because it's incredible. So keep on going, brother.
All right. There we go. We're back. All right. So I got through rule 1 of 3. And we're right towards the end now. So back to this. Remember, these were rules for all electric homes I try to abide by. Rule number 2 is not all electric HVAC systems are created equal. I mentioned this before in electrification. We're not talking electric resistance heat, right? For our sake, we're talking about cold climate air source heat pump systems, right? They are a must. This is not what David mentioned at the beginning. When you get at about 47 degrees or so, it starts to drop off capacity. We're talking about cold climate systems for our cold climate applications. Yes, we have regular heat pumps as well, too, for non-cold climate applications, but now I'm saying 100% of my heating output at 5 degrees or 100% at -5 degrees, depending on the model that you're choosing. So really, really sufficient heating supply at cold temperatures. Second down there is inverter-driven compressors make all the difference. So we're not talking about your regular heat pump, and we're also not talking about your regular heat pump in terms of your regular single stage, remember, all on or all off system. We're variable capacity air source heat pumps. That's what makes the difference for energy usage, comfort, and efficiency. Variable capacity, cold climate for cold climate, air source heat pumps. What does that look like talking about cold climate production? This is just a snapshot slide of our multi-zone hyperheat systems. As you can see, it's 100% heating capacity on those at 5 degrees. And dependent upon the model, you could be at upwards of 93% heating output still at -13. And then it goes still beyond that. So really, really substantial heating performance in cold climates. Rule number 3, HVAC design is crucial. Number 1 talked about why sizing is important and all these other things, but design makes all the difference. Take a look at these pictures here. Mark mentioned it before. We think these things are sexy. You can't tell me that picture of that on the left-hand side with that black wall mount unit isn't a sexy looking wall mount unit, because it really, really is. If we're designing with ductless equipment, it isn't just your old run-of-the-mill wall mount ductless units anymore. There is just a wide variety. Floor mount, wall mount, look on the right, ceiling cassettes. Let's take it off the wall, put it up in the ceiling. So we can design this appropriately with ductless units or a mix of ducted and ductless, which we'll look at.
I was looking at the second photo, the one on the far right, and I didn't actually see it. I was clearly staring at the staircase as the designer and fabricator wanted me to, but it's in the right spot. You have a joist opening there, so you can get it over, and it's not only, I'm assuming, in the right spot for what the structure allows, but it's in the right spot so that you have a span of which you can effectively improve the climate for where the occupants' people are in the space. Right.
I don't want to heat and cool that stairwell. No one's hanging out on the stairs.
Right.
Let's get that air where the people are in the space. That's the beauty of ductless equipment. There's putting that conditioned air right where we need it. Right? We don't have to worry about duct loss. We don't have to worry about keeping ducts in conditioned space because there are none. So let's get that conditioned air right in the space where we want it. In relation to that,
there's also no solar shading in that second photo. So it's really good that that system is there because you're balancing that space so that you're comfortable, right?
Right. Absolutely.
I'm going to mute myself.
Absolutely. So think about ductless, and I said before, there's ways to integrate it, right? Keep it low on the wall. If we can't put it high, we got to put it high. They don't want to see it for whatever reason, even though it's a beautiful piece of equipment. You can recess it appropriately with design considerations, or like that picture on the right of the slide that Mark was talking to, take it off the wall, recess it into the ceiling. Fits between 16 center joist spacing. It will get in there, and it fits in beautifully and works great if you want to get it off the wall. But let's say we don't want to use ductless systems, or we have larger spaces or multiple spaces that we need to consider. We can I'm sorry, I missed a slide. I forgot this one was in here. When we talk about high performance homes, which is what we should be talking about when we're electrifying, I will probably have a lot of zones in that home, smaller bedrooms, other areas that don't have enough capacity to warrant their own ductless system. So let's share some of that conditioned space through transfer fans, inline fans, air share applications. Let's take 2 rooms next to each other that may not need their own indoor unit in there and share some of that conditioned space through air sharing strategy. That's just something that we can do in high performance homes from a design. That's why the design is crucial when we're talking about utilizing these systems. Rule number 3, still on the same one, is now let's look at ducted systems. right? Now, what if I don't want to use ductless equipment for whatever reason it might be? Maybe it's a preference, maybe it's application that doesn't make sense. I can go very traditional with a full air handler, or we have horizontal style air handlers, which you can see on the right, that I can fit in much tighter spaces. Still, let's plan on keeping everything in the conditioned space. As we can see in this attic, you see the spray foam, it's in a conditioned space. So let's utilize that. Why do I want to use a ducted system? Maybe I have a much larger space that I want to take care of that needs better air distribution than a ductless unit can do. Maybe I have multiple smaller zones that don't require their own unit. I can use some ductwork in that. We're not anti-ductwork. We're pro-ductwork as long as that ductwork is controlled and installed effectively. Ductwork is great. Let's just utilize it right. If we talk a little bit more about those horizontal units, Mark, I'm going to ask you a question. I'm going to put you on the spot. Hopefully you're listening to me because I can't see you. If you look at these three pictures and you can see the Mitsubishi unit in there and the ductwork's in there, what benefit is this from an energy efficiency standpoint?
Well, it looks like you have it in the occupancy space, right? You don't have it in perhaps a cold basement or a hot attic. It would be my
right. That's exactly right.
And it's inside almost like the interior air barrier in a way, because that drywall is stopping it. I'm also looking at the taping and mastic, which I like.
Yeah. It's keeping the key with those horizontal ducted units. When I say those, you picture them, what do they look like? That's why I like to show these pictures. Think of like a pizza box or a couch cushion, depending on the size. You can keep them small. They're compact. You can keep them inside the conditioned space a whole lot easier than a traditionally sized air handler, right? So it's not anti-ductwork. It's using ductwork appropriately. Keeping it inside the conditioned space benefits with efficiency, comfort, health, because we're not pulling in attic or crawl space air, anything else associated with that. Very, very important. We can do that with ducted systems if done appropriately. That's why the design is so crucial.
The next thing I'll say with that is for the installers, right? Your access is you walk in, you set up your ladder support, and you pop it in. You don't have to climb through an attic porthole or go down to the basement, because the basement steps aren't in yet, right? They're definitely not in yet. So it's access, and it's really easy serviceability with the 2-foot short ladder, or if you're tall, you just reach.
Right.
So just some questions on this, Mike. I have two questions. First one is going to be in regards to the picture on the far right, or the one in the center that's showing it before it's covered up with sheetrock. So basically, that's just a drop ceiling at the entrance there to get that duct. That's not a drop ceiling through the whole unit. You're just using the efficiency of that space in the hallway to bring that performance to the remaining part of the home. So people are looking at this. They're not thinking, well, either I got to go 10-foot ceilings and drop down 1.5 feet, 2 feet, or 16 inches. This is just an efficient way to use a small piece of space in the hallway to get the efficiency you're looking for. Is that accurate?
Exactly right. You can drop the ceiling for where the unit is located at, or you can do a modified truss design as well, and basically raise your truss design and create your own cavity, and then keep the same ceiling height throughout the space.
Yeah, if your trusses don't allow, you set it just right. Then what Dave pointed to is your hallways, your closets, and your bathrooms are perfect areas. So the rest of your areas, you're getting that height, that comfort design level that people grow to love, and contractors charge for. Right? You charge for that experience.
Right.
Yep. And my second question is this. At Mitsubishi, if I am a contractor, a mechanical contractor, or a homeowner, or a DIYer, will you help me design the most efficient system for my use, or do I have to find somebody that's trained in this? How does that work?
So there's a multitude of benefits of doing business with Mitsubishi Electric, but one of them is access to our internal staff. So I work for Mitsubishi Electric, right? I don't cover multiple different brands. So I am here to help with that. There's a couple things we can't do. One of those is we can't do the load calculation, and we can't do the exact duct sizing right from that end. That's on that. But if you have the load calculation and what you want to accomplish, 100%, that's what we do every day, is help you design the appropriate system for the home. Picking out the right equipment, the right locations, the right distribution. Absolutely.
And if do you have certified contractors in all the different states to where if I'm looking for somebody that understands your system, that has been trained on how to do these things, can I reach out to Mitsubishi or reach out to Mike Schaefer and get a name?
Yes. Write this down, everybody. Mitsubishi Electric, MitsubishiComfort.com. So MitsubishiComfort.com. You can find
mute myself now.
All our locators right on, dealer locator right on there. There it is.
So some of these systems, this one happens to be the ducted, but a lot of the third party systems out there require duct testing. So the other units we covered today, and then it has to be a specific installer with specific credentials. It's not just anyone out of the phone book. So the other systems we saw today, you do not require that additional testing because they are ductless. I probably went into the weeds with that, but when you're going for those third party things, you're gonna have duct testing. And with many of these other systems we reviewed, there's no ducts, so there's no testing.
Absolutely. I'm right at the last couple here because I know we're probably over anyway. So I'm right at the end here. Mechanical ventilation, right? That was part of the topics. We've talked a lot about it already today. Whatever that ventilation method is, we absolutely have to do it. There's multiple reasons, right? It's not just because of you built a tight home, it's code required. Now, it's health is so important to mechanical and proper ventilation. I think we covered it today already talking about it, but it is so important to the health of the home, the functionality of the home, but also when we go back to the HVAC design being crucial, how are we going to integrate it, right? If we're all ductless, then it's a decoupled system, which means it has its own duct system. If we're ducted, we can merge together in that aspect of combining duct systems. But we also need to keep in mind when we're integrating ventilation into a home from the HVAC designer and contractor side, you are now bringing in a load into a house that was never probably figured into doing that. So imagine yourself in a very cold or a very hot and humid climate, and now you're integrating air ventilation into that home, and you didn't figure in for the extra 5,000 BTUs of heat load you're adding to the house now. So it's very important to figure those things into the equation. It can be done. It can be done the right way, and there's many ways to do it. We talked about, Alexander's really great system, the Minotaur system that's out there. There's lots of other systems that are out there, but just it's important, however you do it, to focus on the ventilation, and please pay attention to the ventilation because it is just so utterly important and can be a huge missing piece of the home or a misapplied piece of the home if it's not done correctly.
Sometimes when people have their houses, Dave and Mike, you also have, I want to add a family room or I want to add a bedroom. And that doesn't mean you have to update your system for the rest of the house. Those are a perfect time in most cases. This is a general statement, so ask your team. But in most cases, you can add a really nice ductless mini split, a wall hung or a cassette, and now that room is essentially on its own zone. And, because sometimes you might have a barrier of even getting a trunk or something over there, which you would have to totally resize, and it may work now there, but not somewhere else. There's a whole lot of things. So have your electrician run a line over there, and boomski, that room is taken care of.
Yep. I mean, we spent the whole time talking about a whole home, right? But like Mark said, there's a lot of times we do so much in one zone, one area of the home. You know, we're supplemental, we're additional to a system that's already there. We're a better way to take care of this additional space in the house that may or may not have heating and cooling in it, or just doesn't get good heating and cooling in it, right? Think of the 2-story home. You've got hard time cooling that second floor of a 2-story home on the longest duct runs in the house. So we have that whole portion of the housing market that's out there that we can address as well too.
So Dave, to touch on your soapbox, I want to give a success story, and Mike doesn't know this coming. A success story is making boxes off-site and putting the Mitsubishi system in it and delivering them on site and running them 365 days a year in the hot and the cold of winter. I've done it with many boxes, and I got the right units from Mitsubishi. And to this day, I've had nothing but we love it. That's that. So when you don't get a call back, that means that everyone involved, the construction team, the people that modeled the volume of the space, was right on. So we got the units. They had never worked with Mitsubishi before. They certainly called and learned, and might have later been certified by you guys. But we had multiple units go out. To this day, nothing but success. So it's sometimes we don't give endorsements, but this is an endorsement I'm giving that we've had success, and I like to convey that.
Thank
Awesome.
you. Awesome.
Quick.
Awesome.
Let me throw a quick question in there, and that'll be the last question for the show as we go through the slide. What is the sound noise impact of bringing the unit into the occupancy area? Jeff Connolly asks.
Well, Jeff, when you're utilizing those units that I showed you, it's such a minimal impact. Odds are you're not even going to notice it. So something we don't tout, I don't think, enough on our equipment is the extreme low noise.
Uh-oh. I am not sure if they are frozen or I am. All right, everybody, listen, if you are still out there following along, we are having some sort of technical difficulty here. Let me see what I can fix. I see Mark. Mark, you with me?
I'm not sure if you could hear me.
Jeff's frozen on that, and it looks like he's reloading. So let's see what's going on here. I don't know. It's definitely not on my end. I got full. You with us, Mike?
I'm with you.
Dave, the Blue Angels just went blank. The Blue Angels just flew over. So, thanks, guys. Fly safe. It was a BS pause.
Well, let's get back to the presentation so we can finish that up.
We're right at the very end here anyway. What I wanted to do from equipment is just show a couple projects so you can actually real life put this into something and see what that actually looks like and how you can integrate this. So real quick, I just want to go through 2 different projects that pick 2 different climate zones. So this here is actually our CEO's house down in Georgia. So, warm, humid climate down in Georgia. It's called the Monroe Farmhouse, but it's our CEO's, Mark Kuntz's home down there. So he actually wanted to walk the walk and built a new home, and all electric. As you can see, the solar PV there, and Mitsubishi, of course, for heating and cooling in the home. You can see some of the equipment in here, the outdoor unit, a ductless indoor unit. What was in this system? It's a mix. So I talked about ductless, I talked about ducted, but I didn't talk about a mix, right? So this home has that. It has a mix. In all of the bedrooms, they have their own ductless wall mount unit. And then the main living area has a horizontal ducted unit that's actually ducted to condition that space. So it's a mix of ducted and ductless. And then as you can see in the center by that walk-in closet, there is a whole home ERV providing fresh air and ventilation into that space. Really great house, minus 13 on the HERS scale. So a massive monthly bill of $10 on this house from an energy standpoint. So extremely efficient home. It was the 2019 Dewey Housing Innovation Award winner, 2020 Green Builder Magazine Home of the Year. Just a fantastic home. And I think just to see our CEO building this home and doing the right things when he was doing it just means a lot to me and everything that we go out and talk about every day. So that's a warm climate. So what about a cold climate? So Mark, about our friend here, Benjamin Van Horn with Green Line Homes, been working with him for years. We've done dozens of homes like this. These are all electric homes, south side of Chicago. So a lot of infill property on the south side of Chicago, and he does a ducted, ductless mix depending on the home, some different designs, but these are all electric homes. They're not small. They're 3,000 plus square foot or so. You can see them there on the left. Very, very tight in terms of zero lot line capability, all electric, solar, really, really energy efficient, well-built homes. You can see on the picture on the right, a ductless unit taking care of that main living space. There's a couple different designs that he does, but I like to show pictures. Look at that zero lot line and where you can fit an outdoor unit.
Wow.
Mitsubishi heat pump. It's tight, right? You're tight there, but you can fit it. You can't fit a traditional air conditioner right there. It just doesn't fit. And there's some pictures of a ducted system that we have.
Benjamin's projects are all this impeccable, Dave, since day one out of the gate. I've seen most of his work, and I've even been involved in the testing on some of the projects. And our plug to the Green Build Home Tour, because Benjamin's been on there, and they're brilliant. So this shows you how well it works when you work with a developer that's this keen on results.
Right, and we talk about cold climate, right? It gets cold here. So we can show all the pictures of Georgia and Texas and Florida all you want, but these are cold climate applications, and they just work flawlessly in these homes. This is my contact information. So that's the end of my spiel from me today. So if you need anything in relation to HVAC, if you want to run something past me, if it doesn't relate to my equipment or our equipment is not the right fit, I'll tell you. Please don't understand that. I'm here to help. So I've told many people before, our equipment will work, but you're probably better doing something else in this application. I would rather do that than try to misapply a system for you. Please reach out. Let me know. I'm here to help. If I'm not in your area, I'll connect you with the right people. I've got a great team of people across the country that can help out.
Yeah, for sure. Great presentation. In fact, we've seen it several times over in the comments. So, listen, I think this is going to get a lot of rewatches. And I also think not only for people that are in our group, but for those of you out there that are new to building science and really understanding better air quality and really understanding one of the better systems out there, such as Mitsubishi systems and Minute Air and some of the other ones we've had on the show. Outstanding. I think this was awesome.
I think we're going to use this the YouTube link. We'll pop it on social media throughout the coming weeks, Dave. And Mike, what we'll do is we'll of course tag you. So apologies in advance. We're going to tag you. We're going to tag Mitsubishi Electric Train US. The presentation was very instructional, and we're gonna use that to help support the Green Build Home Tour over the next several weeks of running these out. I agree. I know you got more stuff coming out. I've seen a dozen plus of your presentations over the years, Mike. Really a lot of progress and advancements. I've seen your catalogs go like this, right? The one you gave me the other day, I was like, holy smackaroonies. Smackaroonies. When I say holy smackaroonies, I mean it. So you're really dedicated to our marketplace, and I know you get the support from your team. Dave, for an example, on one of the Green Build Home Tours, probably other ones, I managed to get to, I think, 16 out of 18 of the projects. And this is on the weekend, right? When people are on their free time. The Mitsubishi staff donated their time to go to those sites and volunteer and to get the word out about energy efficiency in the marketplace. It wasn't a Mitsubishi thing. It was a dedication. And that's the difference when you come to Dave Cooper Live. It's about the people that are sharing. It's about the people that are doing it for the greater good. So Mike didn't call up and ask to be on the show. Mitsubishi didn't call up and ask. It's because of the efforts they're doing for our industry that we said, can we provide that voice so you can share to more people?
Yeah,
Thank
for
you.
sure. It really is. And it is invite only on our 3 shows each week. And well, actually 4 with Coffee with Dave as well. So, all right, listen, Mike, what is your one thing? If you're going to leave us with anything today, what would be the one thing you would like to leave us with?
Look at air source heat pumps. Look at variable capacity air source heat pumps. They can do it. It's the solution. It's the solution to heating and cooling your homes and your businesses. Variable capacity air source heat pumps.
I love it. I love it. All right. So here we have next Saturday with Dave coming up tomorrow. I am going to have a special guest join me, Felipe, for just a little bit in the morning. It's a new friend that I have made, and he has his own podcast as well. And Mark, you're going to be joining us again, too. I know we need to catch up on that. Text he sent me like a week and a half ago. I was late to respond. But
I'm joining you tomorrow. You want me to be Felipe? What?
No. I have a Felipe.
I'm messing with you, Mark. Brother. Okay, so but tomorrow anyhow, Felipe's on Coffee with Dave. Got it.
Coffee with Dave. But we are also on Tuesday live streaming from the factory showroom floor of Boxable in Las Vegas. So we are packing up, heading to Nevada, another desert state. We've been in the desert for a while now, but we are going to be at Boxable. Elon Musk recently bought a Boxable. It's getting a ton of press, and we are going to be one of the first ones to show you inside their new manufacturing facility that they're just getting ready to roll off. So that's going to be a great show. And with that coming, Mark, who do we have on BS Friday next week?
So next week we have the team of 4, 7, 5, right? So there's a couple players on that team coming aboard. You're going to be surprised with what we roll out. We've done a rehearsal already. One of those faces, y'all know, it's Mr. Helicopter Man himself, the Canadian flag wearing Sean St. Amour. And so that's Friday at 10 Pacific, 1 Eastern. So I don't know where you're going to be, Dave. So your time zone changes. But that's next Friday. And are you guys taking a break Monday then to do the Tuesday show?
We are. Well, we're not going to take a full break. We will do a small show and rerun probably one of our shows that we already had. But the following week, good thing you brought it up, the week of the 9th, Mark, outside of BS Friday, we are doing no shows. We are taking a vacation, first time in over a year and a half, to where the only show we have that week will be BS Friday. So with that said, we are taking off that week.
I'll add that. I'm glad you're taking a break. 6 shows a week. My goodness, my golly. Sometimes more than 6. We're taking a break from my other show, Dave, in all of August. So now you can bug me even more. But a week from next Friday, so 2 weeks from today, it's the only show Dave's doing. Talk about Twitch. We're going to be diving into Discord. Have you heard of Discord?
I know Discord very well.
Yeah, we're going to have a 17-year-old that won the wall assembly competition, that has one of the most popular Discord channels, and he's launched another Discord channel just for building science and high performance. His name, Dylan Angui.
Dylan Angui. And you know what's funny? Twitch is new to our audience. Discord's really new to our audience. So that's a whole nother level to dive into. But Discords are basically a place to go and connect and chat and find people with the knowledge. It's a great conversational tool for sure. Awesome, Mark.
Every call I've been on this week, Dave, has been on Discord, not on Zoom. It's all been on Discord.
Yeah, Discord's a cool place. It is a super cool place. I don't know how much more we can add into new cool places, but let's give it a shot.
Yeah. I say the one thing we're going to add is more electrification from our buddy Mitsubishi Mike, more ventilation from our buddy Mike at Mitsubishi. And Dave, you have a blessed weekend. I'll join you for coffee. Mike, you're welcome back anytime, all the time, every day, all days.
That's it.
Thank you
That's
so
it.
much, guys. Thank you everyone for listening and attending today too.
Yeah, glad to have you, Mike. That was a great presentation. Mikey likes it. That's what I'm leaving away with this. All right, everybody, listen. So have a wonderful, wonderful weekend. If I don't see you, but join us tomorrow, 6 a.m. Pacific time. Didn't think that one through. 9 a.m. Eastern time for Coffee with Dave. We will see you tomorrow morning. I'll catch up with you all soon. Bye now.